Welcome to today's video, where we dive into the fascinating concept of wireless energy transfer at a global scale. Imagine a future where electricity flows seamlessly across the planet, without wires, power lines, or geographical limitations. From space-based solar power to innovative ground systems, this technology could revolutionize how we access and share energy worldwide. Stay tuned as we break down how it works, its benefits, and the challenges ahead. Don't forget to subscribe for more thought-provoking content. Number 5. Efficient transmission. Efficient transmission is a core challenge in wireless energy transfer, especially when scaling to a global level. Unlike traditional wired systems, where energy loss occurs mainly through resistance in cables, wireless systems face losses due to distance, interference, and atmospheric conditions. Advanced technologies like resonant inductive coupling, microwave transmission, and laser-based energy transfer are being developed to minimize these losses. Resonant inductive coupling allows energy to jump between coils with minimal dissipation over short to medium distances, while microwave and laser systems can transmit energy over hundreds or even thousands of kilometers. Achieving high efficiency requires precise alignment, frequency tuning, and adaptive control systems to respond to environmental changes. Additionally, converting transmitted energy into usable electricity at the receiving end must be optimized to avoid further losses. Efficient transmission not only makes large-scale wireless energy feasible, but also ensures that renewable energy generated in remote regions can reach urban centers without significant waste. As technology improves, global wireless energy networks could provide consistent, low-loss power distribution, supporting everything from industrial operations to residential consumption, and dramatically changing the way energy infrastructure is designed worldwide. Number 4. Economic potential. Wireless energy transfer on a global scale has the power to transform the global economy by creating new opportunities for trade, industry, and energy access. By enabling the efficient transmission of electricity across vast distances without the need for traditional infrastructure, countries can import and export power more freely, fostering competitive energy markets. This technology can significantly reduce the cost of energy production and distribution, especially in regions where building conventional power grids is expensive or logistically challenging. Additionally, businesses can leverage consistent and reliable power supply to expand operations, innovate, and improve productivity. Emerging economies and remote areas stand to benefit the most, gaining access to affordable energy that can drive industrial growth, education, healthcare, and digital connectivity. Beyond just economic growth, global wireless energy transfer can stabilize energy prices by balancing supply and demand across regions, reducing the risk of local shortages or price spikes. It also encourages investments in renewable energy projects, as surplus energy from solar, wind, or hydro plants in one country can be transmitted to areas with high demand. Overall, the economic potential of wireless energy transfer lies in creating a more connected, efficient, and resilient global energy ecosystem that benefits both producers and consumers alike. Number 3. Infrastructure. Wireless energy transfer on a global scale has the potential to drastically reduce our reliance on traditional power infrastructure. Conventional electricity grids require extensive networks of transmission lines, substations, and maintenance systems, all of which are expensive to build and operate. These systems are also vulnerable to natural disasters, technical failures, and energy theft, which can disrupt power supply. By contrast, wireless energy transfer can deliver electricity over long distances without the need for physical cables or complex grid networks. This means fewer transmission losses, lower installation costs, and reduced environmental impact from constructing new infrastructure. Remote areas, islands, or regions with challenging terrain can receive energy without the logistical difficulties of laying power lines, making electricity access more equitable worldwide. Additionally, wireless systems can integrate with renewable energy sources more easily, allowing energy from solar farms, wind turbines, or other decentralized generation points to be transmitted efficiently to high-demand areas. Overall, this shift could streamline energy distribution, cut operational expenses, and provide a more resilient, flexible, and scalable energy network capable of supporting a rapidly growing global population. Number 2. Renewable integration. Wireless energy transfer has the potential to revolutionize the integration of renewable energy sources on a global scale. By allowing electricity generated from solar, wind, hydro, and other renewable systems to be transmitted efficiently over long distances, it overcomes one of the major limitations of renewable energy: location dependency. Solar farms in deserts, wind turbines in remote coastal regions, or hydroelectric plants in mountainous areas often produce abundant energy but are far from population centers. Wireless energy transfer can bridge this gap, ensuring that clean energy reaches cities, industries, and communities without relying on extensive grid infrastructure. This seamless connectivity also allows for better balancing of supply and demand, as energy can be rerouted in real time from regions with surplus generation to areas facing shortages. Moreover, integrating renewables globally reduces dependency on fossil fuels, cutting carbon emissions and supporting climate goals. It also encourages the development of large-scale renewable projects, knowing their output can be efficiently shared worldwide. In essence, wireless energy transfer serves as the backbone for a future where renewable energy is not confined by geography, making sustainable power universally accessible. Number 1. Future connectivity. Wireless energy transfer at a global scale promises to revolutionize how electricity reaches remote and underserved regions. Traditional power grids often struggle to extend to isolated areas due to geographical, economic, or political challenges. With wireless energy systems, electricity can be transmitted without the need for extensive infrastructure, such as power lines or substations. This approach not only reduces the cost and complexity of energy distribution, but also ensures that communities in remote regions gain reliable access to power. Such connectivity can support essential services like healthcare, education, and communication, which are heavily dependent on electricity. Moreover, wireless energy can help emerging economies leapfrog traditional grid systems, accelerating industrial growth and technological adoption. By enabling a network of energy hubs capable of sending power across vast distances, these systems can also balance supply and demand on a global scale. Additionally, integrating wireless energy with renewable sources can provide sustainable and clean power to areas previously reliant on fossil fuels, reducing environmental impact. Ultimately, this technology holds the potential to create a more inclusive and interconnected world, where energy accessibility is no longer limited by location or infrastructure constraints. Thank you for watching and exploring the groundbreaking idea of wireless energy transfer with us. The possibilities of powering the world without traditional infrastructure are truly inspiring. If you enjoyed this video and want to see more discussions on future technologies, make sure to subscribe and stay connected.